Morning viewers, this is Kasturi Day. Today I am going to start with covalent bond of the chapter Atomic Structure and Chemical Bonding according to ICSE syllabus class 9. Okay. So covalent bond is left and some ICSE pattern questions along with some back questions chapter. Okay. So for that you have to be with me. And for that, you have to subscribe my channel if you have still not subscribed, and please ring the notification bell because this will notify you as soon as a new video is uploaded. Okay? And if you like the video, press the like button, share with your friends so that they can also be benefited from these videos. And also, don't forget to meditate before starting your day. So let us begin with the meditation. For just 1 minute, and then we will start with the discussion for today. Okay. So for meditation, please concentrate on the point of light. See the light coming from that point. The whole body is lightened up with that. These light rays. Whatever you are doing, you're happily doing their job. All your energy and you are becoming successful. The thoughts and appreciating you. God, continue. And we'll start with the discussion. In my last video, I discussed about the electrolyte bond. There, the ions are exchanged. That is, there is electrons are exchanged forming ions. Okay, if it is giving an electron, if it is giving electron, then it is becoming a positive charge, positive ion, that is cation. Anion, and if it is gaining the electron, then it is negative ion, that's the cation. Okay? So now we start with the covalent bond where there is sharing of electrons. Okay. All discussed about this electron dot diagram and all those where there is a give and take of the electrons forming cations and anions in the electrovalent bond. Now there is sharing of electrons where there is covalent structure is formed. So what is covalent bond? Covalent bond is a bond where there is interatomic. The bond is an interatomic bond which rises from the sharing of electrons. Okay, they do not transfer from, but they share electrons, okay, between two atoms, and that is covalent bond. The electrical attraction of their nuclei for the identical electrons causes this binding. In this case, in this binding, what happens? There is an electrical attraction of their nuclei for identical electrons. Electrons are similar, and there's an electrical attraction between the nuclei of these identical electrons, and these causes the electrocovalent binding. Okay, when the total energy of the bond atoms is lower than that of the total energy of the bound atoms is lower than that of the widely spaced atoms, a covalent bond is formed. See, uh, the atoms which are bound together. Okay, so those atoms have a energy which is low. This electrical energy that is lower than the energy of the widely spaced atom. Atom, we know there's a wide space in it, so that energy is more than the bound atoms. That time, what happens? The covalent bond is formed. Okay, now elements have very high ionization energies. Okay, and are incapable of transferring electrons, and elements having very low electron affinity cannot take up electrons. So what happens? Elements which has very high ionization energies, that is much energy is required to break the elements into their cations and anions. Formation of ions, their energy is high, energy is required. At that time what happens? Electrons are unable to get transferred. They do not get transferred from one atom to another. So that time the elements, they form this covalent bond, where, and also elements which have a low electron affinity, that is atoms will not attract electrons. Okay, the elements will not attract electrons from other atom. So that time also it will attract electrons, but their affinity means what? The attraction between the electrons. Okay, so that is less. Okay, so the affinity of the electrons is less. Then what happens? Then also what happens? The electron will not get transferred from one atom to another. That time this covalent bond is formed. That is, there is sharing of electrons. When there is no transfer of electrons, that time sharing of electrons happens. Clear? Now the atoms of such elements tend to share their electrons with the atoms of other elements or with atoms of the same element. Okay, so such elements which has very high ionization energies, which has very low electron affinity, they will tend to share their electrons between atoms of the same element or of the atoms of other elements. Okay, in a way that both the atoms obtain the octet electronic configuration in their valence shell. Okay, and thus achieve stability. Without forming the octet configuration, an element cannot be stable. An atom cannot be stable. So for that atom to be stable, they have to transfer electrons, or they will to form the octet or duplet, but they will have to share electrons to form the octet or duplet. So for forming this octet configuration or this duplet configuration, they will have to share these electrons. In case of this covalent bond, share their electrons with other atoms of the same element or of the other element. Clear? To attain the stability. Now, such association through sharing of electron pairs among different and the same kinds is known as the covalent bond. Clear? Now, the covalency of an atom is the number of its electrons taking part in the formation of the shared pair. So, how many electrons have been shared between the two atoms? That gives the covalency of an atom. Okay. Now, covalent bonding can be achieved in two ways. Okay. Sharing of electrons between atoms of the same kind, for example, formation of hydrogen, chlorine, oxygen, etc. Okay. When these atoms are formed, okay, the sharing of electrons between, these molecules are formed between what? Between the atoms of the same kind, that is hydrogen molecule between two atoms of hydrogen, chlorine molecules between two atoms of chlorine, oxygen molecule between two atoms of oxygen. So sharing of electrons between similar atoms. Okay, then same atoms of the atoms of the same kind, and sharing of electrons between atoms of different kind, like formation of methane, CH4, H2O, NH3, etc. Now, as per the electronic configuration of carbon, it needs to gain or lose 4 electrons to become stable, which seems impossible. Okay. So, in case of carbon, we see that it has 4 electrons in its outermost shell, in its valence shell. So, either it has to give away the 4 electrons or it has to take 4 electrons to form the octet configuration in the valence shell. So this becomes impossible. Why? Because carbon cannot gain 4 electrons to become C4, C4 negative, C4 minus, because it will be tough for 6 protons to hold 10 electrons because it has 6 protons in its nucleus, and it will be very difficult. It will be very difficult to hold. If it gains 4 electrons, that means it will the number of electrons in it will be 4 plus 6. So that means 10 electrons it will have. Now, to have this 10 electrons, to hold this 10 electrons with 6 protons, that is impossible, and it will make the atom unstable. Okay. Now, if the carbon loses 4 electrons, that means what? That means it will have how much electrons? How many electrons? 2 electrons. And proton will be 6. So that will also make it impossible. Okay, that means if it removes 4 electrons, then it will be C4 plus. So it will hold only 2 electrons held by 6 protons, and that will also become unstable. So carbon cannot gain or donate these 4 electrons. So to complete its nearest noble gas configuration, that is to form the octet configuration, it will share electrons to form a covalent bond. So it may be with the same, same atoms of the same kind or now. Covalent bonding, what are the properties of covalent bonds? Covalent bonding does not result in the formation of new electrons. New electrons are not formed. The bond only pairs them. No electrons are formed. They pairing them. Sharing of electrons, that is, so they will pair electrons. The bond. Okay. Pair the electrons. Then they are very powerful chemical bonds that exist between atoms. Okay, these shared electrons, they will have a very powerful chemical bond. A chemical bond normally contains the energy of 80 kilocalories, of about 80 kilocalories per mole. Okay, so chemical bond normally has the energy of 80 kilocalories per mole. They rarely break spontaneously after it is formed. When it is formed, this covalent bond, after it is formed, it rarely breaks spontaneously. Very difficult to break this bond. In covalent bonds are directional, okay, where the atoms that are bonded showcase specific orientations relative to one another. Okay, they are directional, where the atoms that are bonded showcase specific orientations relative to one another. And most compounds have covalent bonds which exhibit relative low melting points and boiling points. Okay. As this bonding is strong, so they usually do not melt. They have a low melting point and low boiling point. That is, they will boil very easily and they will also melt very easily. And these bonds are directional. They will have a direct, these bonds are formed in a specified direction. Okay. Specific orientation is there to form this bond. Then compounds with covalent bonds usually have lower enthalpies of vaporization and fusion. That is heat of vaporization and heat of fusion. They have, as their melting points are low, boiling points are low, therefore they will also have heat of vaporization and heat of fusion that will also be low. In compounds formed by covalent bonding does not conduct electricity due to the lack of free electrons, because they do not ionize, and that's why they do not have free electrons, and therefore they do not conduct electricity. Okay. Now, covalent compounds are not soluble in water because they do not ionize. Okay, so that's why they are not soluble in water. Now, depending upon the number of shared pair of electrons, how many electrons are shared depending on the number, the covalent bonds can be classified into single covalent, double covalent, and triple covalent. Now, first we come to the single covalent bond. Single bond. Now, a single bond which when only is formed when only one pair of electron is shared between the two participating atoms. It is represented by one dash between the two atoms. Although this form of covalent bond has a smaller density and is weaker than double and triple bond, it is the most stable. Its density is low, and it's weaker. This bond is weak than double and the triple bond, but this type of bonding is very much stable, the most stable. For example, hydrogen chloride, HCl. It has one hydrogen atom and with one valence electron and one chlorine atom with several valence electrons. See, hydrogen has one valence electron, chlorine has several valence electrons on its outermost set. 7 valence electrons, 1, 2, 3, 4, 5, 6, and 7. Okay. Now, in this case, a single bond is formed between hydrogen and chlorine by sharing one electron. This electron of hydrogen and this electron of chlorine that is shared. Okay, so that forms hydrogen chloride. Okay, making a one dash between hydrogen and okay. Like that, hydrogen when it is combining, it is forming, sharing one electron of hydrogen with the other, another electron of the another hydrogen atom. Okay, so forming a single covalent bond. Chlorine also, one electron is sharing between them and it's forming a covalent bond. Then methane also, one carbon has 4 electrons on its valence shell and each hydrogen has 1 electron on its valence shell. So one carbon atom, one carbon atom has 4 electrons. So each electron from the carbon will share with one hydrogen atom. One electron of the hydrogen atom, the valence electron of the hydrogen atom forming a methane, that is CH4 is forming. Water has 2 oxygen atoms on its outermost shell, so it will share with 2 hydrogen atoms. Okay. Then chlorine also, a carbon also sharing each one electron, as it has 4 electrons on its outermost shell, so it will share 1 electron of its atom with 1 electron of the chlorine. So what happens? Carbon shares 4 electrons with 4 chlorine atoms. Then ammonia forming carbon tetrachloride. Then ammonia has 3 electrons on its outermost shell. So it will share 1 electron each with one hydrogen atom. So it will form NH3, right? We come to double bond. Now, a double bond is formed when 2 pairs of electrons are sharing, okay, between the 2 participating atoms. Like in single bond, 1 pair was shared. Here, 2 pairs of electrons are shared. Now, 2 dashes will be there between the bonds. So, and it is much stronger than the covalent bond, and it is less stable. Stronger, the bond is stronger, but the compound is less stable. Okay. The carbon dioxide molecule has 1 carbon atom with 6 valence electrons and 2 oxygen atoms with 4 valence electrons. Okay. I'm sorry. The carbon atom has 4 valence electrons on its outermost shell, and oxygen each will have 6 valence electrons on its outermost shell. Okay, so to complete its octet, carbon shares 2 of its valence electrons with 1 oxygen atom and 2 with another oxygen atom. Okay, so as carbon has 4, so 2 with 1 oxygen, 2 with another oxygen. So oxygen requires 2 electrons to form the octet, and carbon will have to lose 4 electrons. So that's why 2 to each oxygen atom, okay, forming carbon dioxide. See, 2 dashes between the carbon and oxygen. Okay. Now oxygen, if it combines 2 oxygen atoms, that time what happens? See, 2 oxygen atoms, that means one. Two oxygen, 2 electrons will be shared between 2 oxygen atoms, forming O2. Again, ethene, that is, ethene is C2H4. Okay, that also, carbon has 4 electrons on its outermost shell. So 2 will be shared between 1 carbon atom. Each 2 carbon atoms will be there. So 1 carbon shares with another carbon atom. 2 electrons will be shared, and the other 2 will be shared with 2 hydrogen atoms. Okay, so this will form this one, C2 and H4. Clear? Ethene. Then we come to triple bond. Now, a triple bond has 3 pairs of electrons on the outermost shell. Okay, with 3 pairs of electrons are shared between the 2 participating atoms. Now, triple covalent bonds are represented by 3 dashes. Okay, and at least these compounds are least stable types of covalent bonds. Here, this bond is least stable, but strongest. But it is still stable. For example, in the formation of nitrogen molecule, each nitrogen atom having 5 valence electrons, okay, provides 3 electrons to form 3 electron shares or electron pairs for sharing. Thus, a triple bond is formed between 2 nitrogen atoms. Okay. Now we come to other 2 covalent bonds. That is, one is polar and non-polar. So first we come to polar covalent bonds. So there are 5 types of covalent bonds: single, double, triple, polar, and non-polar. Now, what is polar covalent bond? This type of covalent bond exists when there is unequal sharing of electrons. In single, double, and triple, we have seen there is complete pairing, sharing of electrons and forming a pair. But when there is unequal sharing of electrons occurs to the difference of electronegativity of the combining atoms. Okay? So more electronegative the atom is, it will have a stronger pull of electrons. More electronegative will it be, it will pull the electrons more stronger. The electronegative difference between the 2 atoms is greater than 0 and less than 2. It should be greater than 0 and less than 2. As a result, the sharing of the electrons will be closer to the atom. Sharing of the electrons will be closer to the atom. For example, molecules forming hydrogen bonding as a result of unbalanced electrostatic potential. In this case, the hydrogen atom interacts with electronegative fluorine, hydrogen, or oxygen, which will be more closer to the atom. Okay. Sharing of electrons will be more closer to the atom. Okay. And the electronegative difference should be is greater than 0 and less than 2. Okay. More electronegative is, the more will it pull the electrons towards itself. Okay. Stronger will be the pull. Like fluorine is more electronegative, so it will pull more of electrons from hydrogen. Okay. Then hydrogen is also an electronegative combination is there. Then hydrogen, oxygen, like that. Then example of polar covalent bond in this diagram, oxygen is more electronegative than hydrogen. So it will pull 2 hydrogen atoms. 2 electrons from the hydrogen. So thus it will be more strongly attract electron shares in the bond between itself and hydrogen, causing the oxygen side of water molecule to be even more electronegative. Okay. So oxygen side will be more electronegative than the hydrogen side. That's why this will be more electronegative, as oxygen is more electronegative than hydrogen. So the oxygen hydrogen bond in water molecule becomes polar. Next is polar. One other covalent bond is hydrogen chloride. As a polar covalent bonding is a type of chemical bond where a pair of electrons is unequally shared between the two atoms with a difference of electronegativity. It is found that hydrogen chloride is also a polar covalent compound where both have different electronegativity. They are more, this chlorine is more electronegative than hydrogen, so it will become, this side will be becoming more electronegative than hydrogen side. Then examples of more polar molecules are water, ammonia, sulfur dioxide, hydrogen sulfide, and ethanol. Okay. Now we come to non-polar covalent bonds. This type of covalent bond is formed whenever there is equal share of electrons. Polar, unequal sharing. Here, non-polar, there will be equal sharing of electrons. The negative electronegative difference between the two atoms is zero. Okay. Now, I told you the electronegativity will be 0 to 2. So, if here the non-polar, the electronegativity difference will be 0. It occurs whenever the combining atoms have similar electron affinity. Diatomic elements, they will have a similar electronic affinity, like hydrogen gas, nitrogen gas. So, similar electrons, similar atoms, and they will have an electron affinity, similar electron affinity between the two atoms. Okay, so they will be diatomic elements, like H2 we write for nitrogen gas, N2 we write. So diatomic elements, they will have the same electron affinity. Their electronegativity difference will be 0. So example of non-polar covalent bonds, any noble gas like helium, argon, neon, krypton, xenon, they are non-technically molecules. These are atoms, not technically molecules. These are not technically molecules, but they are atoms. Okay, but as their octet is full, they will behave as a molecule. Okay? Outer valence shell is full. Now, any of the homonuclear atoms, diatomic elements, like similar nuclear, that is H2, N2, O2, Cl2, they are truly non-polar molecules. In carbon dioxide, CO2, benzene, C6H6, carbon tetrachloride, CCl4, then methane, CH4, ethylene, C2H4, or ethene. Okay, then hydrocarbon liquids such as gasoline, toluene, most organic molecules, these all are non-covalent bonds. Okay. So what is the difference between non-polar covalent, polar covalent, and ionic bonds? See, non-polar covalent bond is there is equal sharing of electrons. Polar covalent bond, there is unequal sharing of electrons. And ionic bond, there is no sharing of electrons. So next we'll start with some examples of this polar and non-polar bond, how they are formed. Okay, so this needs to be explained. So I will discuss in my next video. Till then, please go through this chapter. Wherever you feel any doubt or any questions you want to know regarding this chapter or any other chapter which I have discussed, or any notes to be made, please you can write in the comment box, or you can also email me at my kasturi74@gmail.com mail ID. Okay, so you can do that. If you want any test to be done, you can also write me in my comment box or email ID also you can refer to. Okay, and till then, please go through it and do subscribe my channel if you have not subscribed yet. And if you please ring the notification bell, and if you have liked the video, press the like button, share with your friends so that they can also be benefited from these videos. And don't forget to meditate before starting the day. Okay, so bye bye and good day.